learn about Hund's rule. Hund's rule says that the electrons Hund's rule is used to fill electrons within the orbitals of specific subshells. Hund's rule says that the electron will be first singly filled in the orbitals in a subshell, and then they'll get paired with an opposite spin in the same orbitals. For example, chlorine atom. Chlorine 17 has 17 electrons. So its electronic configuration is going to be 1s2, 2s2, 2p6, 3s2, 3p5. I've explained that how to write this electronic configuration in the previous video. Please refer to that uh, before proceeding. Okay. Now, the Hund's rule is going to tell us how to write the electronic configuration of the electrons within the subshell, within the subshells in the orbitals of that subshell. For example, over here, the 3p orbital has the p subshell has three orbitals, the px, pi, and pz, and it has 5 electrons. Now let's start filling up the 5 electrons according to the Hund's rule. Hund's rule says that they're gonna be filled first singly. So this is the first electron, it filled the first orbital. Then the second electron that's gonna come into this subshell, it won't go into the px orbital but rather will go into the py orbital because it has to fill it singly. Then pz orbital next. The reason why this happens is because these orbitals are easier to get in the non-occupied orbitals. The unoccupied orbitals are easier to get in because the orbital that is already filled with an electron, that electron will repel the incoming electron and make it difficult for it to enter. So the electron will enter those orbitals first that are easier to enter. Then after filling the 3 electrons, 2 electrons are left in the 3p5 subshell. Out of the 5 electrons, 3 electrons have been arranged. Then the next 2 electrons, they'll get paired. They'll get paired, and they'll then next 2 electrons will start filling up the px and py, and they'll get paired now. But in the opposite direction, their spin will change and become opposite to the initial electron. Now, and the last or electron will enter the py and become paired in the opposite direction. This is how we are going to fill the electrons according to Hund's rule. Then the next example is the titanium 23, argon core 4s2, 3d3. Okay. Now, argon core meaning 18 electrons plus 2, 20, and plus 3, 23 electrons. So 18, 2, and 3, 23 electrons. Now, according to Hund's rule, we are gonna fill up the electrons in the d orbitals. The 3D subshell has 5d orbitals, namely the dxy, dyz, dxz, dx squared minus y squared, and dz squared. The three electrons will start filling up singly first, then second, then third, and that's it. This is the electronic configuration of the 3D orbital according to the Hund's rule. Now let's write down the electronic configuration of the 3D6 electrons in the 3D6. Okay, they'll start filling up singly first. So 1, 2, 3, 4, 5. The sixth electron will now get paired and become paired and will occupy the first dxy orbital with an opposite spin now. Okay, now coming to the phosphorus 15. Let's look at the 3p3 electrons. The p subshell has three orbitals as well, px, py, and pz. The three electrons of the 3p will start filling the px, py, pz singly first. So 1, 2, and 3, and that's it. This is the electronic configuration of the 3p3 electrons. So that's it for the Hund's rule. You just to sum it up, electrons gonna are gonna be filled singly first, and then they'll start pairing up with the electrons that are already there but will have opposite spins. Thank you.